So we're going to look at the lesson titled Right Triangles. Again, if you do not have these notes, you can find them in Google Classroom. Also remember that you can pause these at any time if you need to catch up in the writing. And then you can always go back and look at them again. These first few slides are just informative, so there won't be a lot of writing. So the second slide you can see has all 6 of the trig functions: sine, cosine, tangent, cosecant, secant, and cotangent, and what their abbreviations are when we're doing the work. So you're probably most familiar with sine, cosine, and tangent because you probably touch base in those a little bit in geometry. You're probably least familiar with cosecant, secant, and cotangent, but there they are. You now know that they do exist. If you look at the next slide, up here on the top one, you have your basic right triangle. In trig, angles are always labeled using a Greek letter, the most popular one being theta. Theta is like our x in algebra classes. Depending on where that theta is located will help you determine which side is your opposite and your adjacent. Remember, the hypotenuse is always the longest side. It's always opposite the right angle. So the hypotenuse never changes, but depending on the location of theta, your opposite and your adjacent sides can switch places. So here's how you find the 6 trig functions based off which angle they are referring to. Again, if theta moves, then these two are going to change. There's also an acronym that's used to help us remember, which is Sohcahtoa. Sohcahtoa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over the adjacent. There's no acronym for these 3, but you have to just remember that the opposite of sine is cosecant. The opposite of cosecant is secant. Opposite of tangent is cotangent. Not just opposite, but the reciprocal. So if you know how to find sine and you remember that cosecant is its reciprocal, then you can just flip the answer you have for sine and you have the answer for cosecant, and same goes for these last 2 as well. On the bottom slide there, you'll see the 2 special right triangles that you learned in geometry. So you have your 30, 60, 90 triangle and your 45, 45, 90 triangle, and what the sides would be labeled based off those 2 special type of right triangles. Will we always work with the right triangle or special right triangles? Absolutely not, but this is a good starting point for us. And we will be using these to help us with the work that we're going to see on these next pages. So we're going to use the right triangle to evaluate each expression. So you've got your 30, 60, 90 right triangle. Opposite of the 30 is your 1. Opposite of your 60 is the square root of 3. And opposite of your right angle is your 2. So they're asking us to find the sine of 30. So 30 is right here. So if this is the angle they're referring to, then across from it would be your opposite. Next to it would be the adjacent. And of course, the hypotenuse is always going to be the hypotenuse. Sine is found using the opposite over the hypotenuse. So sine would be opposite, which is 1, hypotenuse, which is 2. So 1/2 is the sine of 30 degrees. 60 degrees is right down here. So when we're asked to find the cosine of 60, this is now the angle we're referring to. So that means now that this square root of 3 is the opposite, and next to that square root of 60 is your adjacent. Hypotenuse is still the same. So the cosine is found by using the adjacent over the hypotenuse. Next to it, that means adjacent, the 60 degrees is 1. Hypotenuse is 2, so the cosine of 60 is also 1/2. Cotangent is the opposite of tangent. So if tangent is opposite over adjacent, then cotangent would be adjacent over opposite. Notice the angle is 30. So if we're referring to this angle here, the opposite would be 1. The adjacent would be the square root of 3. So cotangent is adjacent over opposite. So the adjacent is the square root of 3. The opposite is 1. Simplifying that, our answer is just the square root of 3. Cosecant is the opposite of sine. Sine, remember, was opposite over hypotenuse. So cosecant would be hypotenuse over opposite. We're looking at the 60-degree angle on this one. So this is your opposite, adjacent, hypotenuse. So we're looking for the hypotenuse, which is 2, over the opposite, which is square root of 3. Remember, you're not allowed to leave a square root in the denominator, so I'm going to multiply by the square root of 3. So 2 square root of 3 over 3 is going to be my answer. On the next one, we have a 45, 45, 90 triangle. So same thing here. We got the tangent of 45. Now, because these are the same, notice the sides are the same. So it doesn't matter which 45 you're looking at. Let's say we're always going to look at this 45 right here for these problems, because it doesn't matter which one we look at since these two sides are the same. So the tangent of 45 from up here, tangent was opposite over adjacent. So opposite is 1, adjacent is 1, so the tangent of 45 degrees is 1. Secant is the reciprocal of cosine. Cosine was adjacent over hypotenuse, so that means that secant is going to be hypotenuse over adjacent. So hypotenuse is square root of 2, adjacent is 1, so our answer is just the square root of 2. Sine of 45 degrees, sine from earlier was opposite over hypotenuse. So opposite is 1, hypotenuse is square root of 2. Again, you cannot leave a square root in the denominator. So we're going to multiply top and bottom by the square root of 2. So square root of 2 over 2 would be our answer. Flipping to the next page. So they give us a little piece of information here. They tell us that the sine of some angle that they're calling t is 5 over 2. Remember, sine is opposite over hypotenuse. So really quick, I'm going to just quickly draw a right triangle. Doesn't matter what it looks like. And I'm going to pick one of the angles. So I'm going to call this my t. So now I know that the opposite of t is 5. And that the hypotenuse is 7. Look at the second piece of information. It says that the cosine of that angle t is 2 square root of 6 over 7. Remember, cosine is adjacent over hypotenuse. So if this is my t, then the adjacent would be 2 square root of 6. Hypotenuse is 7. So here's what this particular right triangle looks like. So now that we have that set up, we want to find the tangent of t. Tangent, remember, is opposite over adjacent. So if our angle t, this is my opposite, this is my adjacent. So I have 5 over 2 square root of 6. Again, I can't leave that square root of 6 down there, so I'm going to multiply top and bottom by it. So I have 5 square root of 6 over, these two right here would become 6, and 2 times 6 would be 12, and there's my answer, 5 square root of 6 over 12. The cosecant is the reciprocal of sine. Well, up here, we already found, or we're told that sine was 5 over 7. So if we flip that, 7 over 5 would be my cosecant. Secant is the reciprocal of cosine. So if I just flip this one, 7 over 2 square root of 6, again, can't leave that radical down there. Multiply top and bottom by the square root of 6. So I have 7 square root of 6. Again, this becomes 6, so 2 times 6 is 12. There's my answer for the secant. Cotangent is the reciprocal of tangent. So let's start with what we originally wrote for our tangent. Tangent was 5 over 2 square root of 6. So if I flip that, I get 2 square root of 6 over 5, and that's just my answer. I don't have to do anything with that square root of 6 since it's in the numerator. Then we've got something called cofunctions. So remember from geometry that two angles that add up to 90 degrees are called complement or complementary angles. So two functions that add up to 90 degrees are called cofunctions. So if they gave you the sine of some angle, let's say 30 degrees, then its cofunction would equal the cosine of whatever 90 minus that 30 degrees is, which is 60. So this angle measure here and this angle measure that you end up getting over here, when added together, should give you 90 degrees. They may give you the angle measures in radians. That was in our last lesson. So just know that 90 degrees and pi over 2 are equivalent angle measures. This first one is in degrees, the second one is in radians. So you'll constantly refer back to this page when asked for your cofunctions, like they do on this next page. Find a cofunction with the same value as the given function. So the cofunction of cosecant, you flip back over here, here's cosecant, its cofunction is secant. So we're going to write secant, and we're going to take 90 degrees, and we're going to subtract that 42 degrees. So our answer is secant of 48 degrees. The cofunction of cosine is sine. So we would put sine of, now again, like I put on the other page, the equivalent of 90 degrees is pi over 2 minus the pi over 4 that they gave us. Again, you can put these in the calculator. This is really quick. We got to get those common denominators, so that both need to be 4. This one won't change. This one has to get multiplied by 2. So 2 pi minus pi. Remember, this is 1 pi. So if you have 2 apples and you subtract 1 apple, you still have 1 apple left over 4. If you absolutely do not like this, and again, you can use your calculator to help you, but if you do not like this, you can convert this to degrees first and then convert it back when you want to write your answer. The last slide is just an informative slide. Whenever you're asked to find the approximate value of a trig function, if the problem is given in degrees, make sure that the calculator is in degrees, and if it's in radians, make sure it's in radians. So in the calculator, you can hit this mode button here, and you'll see that the third line has radians and degrees. So if I want my problem in degrees, I would scroll down and over on top of degrees and hit enter. You have those online calculators and the cell phone calculator that I provided to you guys. Make sure that you can do that on these as well. So just make sure you read through these instructions anytime they're asking you to find the approximate. That's the key there. The approximate value of a trig function. If you have any questions, I will meet you at 10 o'clock in Google Meet on Thursday. See you then.